Welcome students. Today we are discussing our second chapter in chemistry. It is chemical bonding. In the previous class we have discussed our first chapter and it is completed related with the structure of atom. And today we are going to the next one, it is chemical bonding. So we are going to discuss about our new chapter, it is chemical bonding. So before we want to discussing about chemical bonding, we know that the molecules are formed by the combination of atoms. The molecules are formed by the combination of atoms. According to that, the molecules are mainly divided into three. Molecules are mainly divided into three. They are monoatomic molecule, diatomic molecule and polyatomic molecule. Monoatomic molecule, diatomic molecule and a polyatomic molecule. So the name implies what is the nature of the molecule. Monoatomic, that means the molecule need only one atom. That means the atom is only one, it forms a molecule. Second one, it is diatomic molecule. Di, that implies two. So the two atoms are combined together and form one molecule. Then polyatomic, the molecule that contain three or more, two or more atoms that is combined together and form a molecule. So the compounds are formed by the combination of atoms of different elements. So these are things that we have studied in 8th standard also, okay, about molecule and the compound. Now in a compound the atoms are combining, or in a molecule the atoms are combining. What is the reason for combining these two atoms? What is the need for that? And how they are combined, then how they are stuck together. So these are the things we want to discuss in this chapter, mainly related with chemical bonding. So first of all, in this chapter we are going to the first subheading of the chapter related with the electronic configuration and stability of an atom. Okay, electronic configuration and stability of an atom. For that, in periodic table that include 18 groups. In periodic table, related to the periodic table, we are detailedly studying in third chapter. Now we just mentioning you about periodic table. The periodic table contain 18 groups and 7 periods. 18 groups and 7 periods. The 18th group of periodic table, is known as noble gases or inert gases. So these are the elements belong to the 18th group. So helium, neon, argon, krypton, xenon and radon. These are the elements belong to the 18th group of periodic table. Now we are going to discuss about their atomic number and their electronic configuration. We are familiar with the electronic configuration of elements up to atomic number 18. So in this chapter we are just mentioning the electronic configuration of the noble gases. So look at that. Helium, its atomic number is 2. Then the electronic configuration is the 2. Helium is atomic number 2, that means that I have 2 electrons and the electronic configuration is also 2. The next one, neon, its atomic number is 10, the electronic configuration is 2, 8. And third one, argon, atomic number 18, electronic configuration 288. Then the fourth one, krypton, atomic number 36, electronic configuration 28188. Then xenon, atomic number 54, electronic configuration 28188. Then the last one, radon, its atomic number is 86. Then the electronic configuration is 2813288. Now look at the valence shell of this element. Except helium, you just check the number of valence electron. Valence electron means number of electrons in the outermost shell. Number of electrons in the outermost shell. Last shell is known as the valence shell. The electrons in the valence shell, outermost shell, are known as valence electron. So look at the number of valence electrons in these elements. Here 8, the next one also 8. The other elements also, their last shell, their valence shell contain 8 electrons. If an element in their electronic configuration, the valence shell contain 8 electrons, That electronic configuration is known as octet electronic configuration. If you write an electronic configuration of an element and you write the electronic configuration, later we get the valence shell that contain 8 electrons. That electronic configuration is known as octet electronic configuration. Octet electronic configuration. Octet electronic configuration. Octet, that means 8. The 8 electrons in the valence shell, that electronic configuration is known as what? Octet electronic configuration. So, octet electronic configuration of an element octet electronic configuration. The octet electronic configuration of an element that implies the valence shell of an element in the electronic configuration, the valence shell of an element that contain 8 electrons, that electronic configuration is known as octet electronic configuration. If an element that have octet electronic configuration, that element is more stable. Okay, the element is more stable, the element get the stability, maximum stability. The more stable means that valence shall have the 8 electrons. But look at the case of helium. Is it valence shell contain 8 electrons? No, that have only 2 electrons. But if that is 2, the element helium is also stable because the atomic number is 2 and the electronic configuration is also 2. But the element is also stable because in the case of helium that have only one shell, that means the first shell, K shell. The maximum number of electrons that are possible to accommodate in the first shell, it is 2. So the first shell is completely filled. That's why in the case of helium, this element is also stable. Okay, the octet electronic configuration we are discussed and the case of helium is also discussed. Then next elements, we are going to discuss about the electronic configuration of 2 or 3 elements more. Okay, look at that. In the case of magnesium, its atomic number is 12 and the electronic configuration is 282, and the chlorine, its atomic number is 17 and the electronic configuration is 287. Then oxygen, its atomic number is 8, electronic configuration 26. Look at the 3 elements. Magnesium, atomic number 12, electronic configuration 282. Then chlorine, atomic number 17, electronic configuration 287. Then oxygen, atomic number 8, electronic configuration 26. My question is that, is the elements are stable? Is these elements are stable? No. Why these elements are not stable? Because their valence shell does not contain 8 electrons. That means octet electron configuration is not attained by these elements. In the case of magnesium, 2 electrons are there in the valence shell. In chlorine, 7 electrons are there in the valence shell. In oxygen, 6 electrons are there in the valence shell. There is no 8 electrons. So octet electron configuration is not attained. So this element is not stable. But these atoms of these elements are try to attain their stability. How they attain their stability? They attain their stability by chemical bonding. They attain their stability by chemical bonding. So we are going to discuss about the chemical bonding. Chemical bond is a type of attractive force that will be hold or held the atoms in a molecule. So chemical bonding is a type of attractive force that held the atoms together in a molecule. Okay, it's a type of attractive force. So now we are going to discuss about the chemical bond in the next class. Thank you.